So hello everyone. So today we are going to see all those entire final implementation of whatever till now we have covered, starting from the problem statement, okay, then thinking about whether it is a supervised or unsupervised learning, and if it is comes under the supervised learning, then whether it is a classification problem or a regression problem, and then choosing between two of them, then finding out the exploratory data analysis, then do the feature engineering process, okay. And after doing the feature engineering process, then how to clean up our data set, okay, how to do all those statistical imputation to our feature. And then finally, once our data set is getting cleaned, I will show you to you each and everything in detail, so that from the very dirty data set, making the pipeline to clean the data set, so that our data set is now become production ready, and we can actually train our lots of machine learning algorithm on that data set. And then finally we try to export that machine learning model in a .pkl file or .onx file or .pt file, whatever you want, okay. And then you can directly surpass this to any other team, so that they can actually try and test it out your model, right? So we will see the entire detail and the entire logics of how the machine learning pipeline works, okay. So let me just directly jump in into the problem statement. So our problem statement is this, okay. So I have taken the data set from the Kaggle, and it is very popular problem statement, which is like title survival prediction, right? So why are we actually solving this Titanic data set? Because this data set contain a lot of thing, okay. And this data set can give you a lot of assumption as a user if you're actually training your model, right? So this data set can give you a lot, that why before training any model, how mandatory it is to first of all clean your data set, okay. So first of all, just let me tell you that why are you solving this problem, okay. We are actually solving this problem because this problem has a lot of data, number one. Number two is that this problem has a lot of variety, okay. Number three is that this is very noisy data, okay, which means that if I show you the data, you will just at the very first glance you will tell that what kind of data it is, okay, because this data is not really in practice to train any model, okay. So we will see each and every details about it, right? And the most important thing is that first of all, let me tell you that why we are solving this Titanic data set, okay. Because this data set is actually like contain the passenger detail, okay. The passenger detail, which means the passenger attributes. The passenger can have age, the gender, the class, the fare that they have actually like choose to go into the ship, right? And then try to experience different things, right? Then how many family they are actually they actually had in the ship, right? And how many of them are actually lost their life, right? Because of the tragedy. Then how many cabins that does it have, and can we able to predict like who has survived and who did not, right? So from the data set, is it possible to just find out the survival prediction? If suppose if we have a data set tomorrow, okay, then we if we wanted to find out that whether this person with this id having this age, belonging to this class, belonging to this family, and suppose if they have given up, they have given that many fare in order to experience the entire ship, right? So whether they have actually like survived it in the tragedy or not, okay, and what is the probability of that survival rate, okay. So we will see everything. So basically this is a classical binary classification problem, okay, and this is like used by around 2 lakhs Kaggle users worldwide, okay. That is why I picked this data set. Then again, like beyond the competition, the project also demonstrate the real life production grade data science workflow, okay, from the raw messy data to the clean data. We will do a lot of things. We will do exploratory data analysis till feature engineering, we will do model training, and we will do entire thing in this video, okay. So again, when I give you, so let me just give you the overview of the data, that how does data actually looks like, okay. So this is my data set, which contain the 891 training samples and 418 testing samples, okay. And all these samples are actually contain the passenger detail, okay. And what is our goal? Our goal is to predict the survival using a machine learning model, okay. So we wanted to predict that whether the person is actually survived or not. If the person is actually survived, then it is come under the category of class A, and if it has not, then it is come under the category of class B, okay. And then we will see the deliverables, right? So what are the training like, so how, so after like cleaning all this data set and applying all this major important step, right, then how our data set look like, okay. And after cleaning, like how we are supposed to give it into the post production line, right? So the first important thing is that we will be choosing is that we will be going with the EDA process. And after like finding out the EDA process, so let me tell you a little bit about EDA. I think in the past previous lecture you might have understood that EDA is basically the exploratory data analysis, which means that we wanted to understand about the data, okay. Suppose if I give you a CSV file, right, and if I wanted to do a EDA, if I ask you to do the EDA, right, so you will apply in your knowledge base, whatever the statistical process that you had, right, you will apply all the statistical process just to get the intuition of that data. Okay, because from the very English language somebody give you the problem statement, right, but understanding the data with the process, right, and understanding the very raw set of data, you need to do it like so many things in order to understand and get the insight from this data. Okay, so that is why EDA is very important, and I will show you that from the EDA what I have understood from this data set, right. So I have understood that there is a 38.4% overall survival rate. Okay, and which means that out of this 74% have actually women have actually survived, and only 19% men have actually survived. Okay, and the person who are like the like the people who are actually in the first class deck, right, so they have only 63% survival rate. So we will see there is a very strong predictions that, let's say, between the gender differences, like whosoever the gender is between lying between, let's say, 25 to 40 or 50, right, so they have their chances of survival is getting high, and out of this, if there are majority of the women, then their chances of survival is more higher than the other people, right. And if they have if they have actually already in the ship, and if they have already in the first class cabin, so they have a 63% of survival rate, right. So, and then from the EDA process I also get to know that there are actually women and children first policy. Okay, so from the data, and it is actually not like visible in the problem statement at all. Okay, this is like if I would not have done the statistical EDA process, right, I would not get the insight from this data. That is why I tell you that at the very first part of the machine learning step is actually to do the hands-on practices on the exploratory data analysis, right. And I'll show you everything, don't worry about it, right. And then again, the optimal survival rate is like the family who are actually having the size of 2 to 4, which means that a family who has the sibling, who has the parent, who has the child, right. So they so at that time, like while the ship was sinking, right, so these people have, somebody has given the priority to these people to go out of the ship, right. So so for them, like these were the priority, right, and these are actually the entire findings of the data, right. Then when it comes to, then other part is actually feature engineering, right. So once we understood the data, the whole nuts and bolts of all the data, right, that, and then we will gather some of those points, right. Let's say what I have done is personally is that I have actually there are actually 4 to 5 points that I have understood from the data. Okay, so from this, from the EDA process, I will get a maximum chunk of information in my brain that these things, this data is actually tells to me, right. Then the other thing is that the other thing is that we need to do feature engineering, because feature engineering is the most powerful form of any machine learning pipeline, because without feature engineering you cannot able to clean the data, right. And feature engineering is not about cleaning or imputation of the data. Feature engineering is also finding out the correlation between the two feature. Okay, if the two feature are basically correlated, then I don't need to use that feature. I can simply delete that feature so that my feature size is actually decreased. Okay, other than that, like suppose if the feature is not very not very, the feature is, let's say, very unnecessary, increasing my data set, right, so I would not use that feature. Okay, now suppose suppose if like the person is actually having a surname, and for surname itself there is a separate feature, so I would not, like from the surname I cannot predict that whether someone has survived or not, right, so I would definitely going to delete that feature. Or let's say the person is actually having some name, right, so name also do not, so name also is not very less relevancy when it comes to survival rate, because no one going to, because no one is given priority to like survive if the person is actually having some name. Okay, so name is also a very unnecessary feature. Okay, so these feature, all these things are actually come under the feature engineering part, right. Then from the feature engineering part, I will show you that how I actually like manipulated the feature. Okay, how I actually deleted the feature, how I actually find out the correlation between the features, so that you will get a little more intuition about the feature engineering. Okay, so till now whatever you have understood, the number one is that you have understood about the EDA part of it. The second thing is you need to do the feature engineering part, right. And then third thing is like this one. So the third thing is like basically a data cleaning part, right? Because once you have already done the feature engineering part, then again you need to do the data cleaning part, that whatever, so whichever feature is actually having a row, right, which is like empty, which does not contain any value, right? So there is two way, that either you put that row as actually a zero, or either you take the mean of all the feature and then like try to impute the value. Okay, so these things we will see that how we actually like do a very smart engineering for cleaning our data set. Okay, Then we will do the final like encoding of the data. Now why this encoding is needed, like suppose if any feature contain some kind of a categorical value, right? So for machine to understand, so suppose if it is a classification problem, right? So for machine to understand, right, it is better that you try to encode it. Okay, you try to encode, you try to do the binary encoding, okay, so that your feature is getting like much more visual data representation. Okay, so that I will also show it to you, that how to do this kind of encoding, okay, and why it is actually needed in order to less down the complexity of training, right? Then I think this is just a end-to-end pipeline flow. So let me just go into this. So first of all, whatever you have a raw data, you have very dirty data which somebody has actually given to you. The other thing is that you will do the exploratory data analysis, you will do the feature engineering part, okay, and you will like do the data cleaning part and the imputation part. Then you will do the one hot encoding, the label encoding part. Then you will do the validation and alignment. Then once you come up, like once you done the entire set of steps which I mentioned it before, then finally you will going to save the clean data set, right? So you have a train data set, you have a test data set, you split it, you basically save it into with the extension of dot clean csv, so that you will get to know that this is the csv file that I wanted to like leap it forward in order when I wanted to train my model, right? And yeah, so this is like the, so from by training the model, this is what I have actually gathered the information, right? So let's say that woman is actually having a 74% survival rate and men is actually having a 19% survival rate. Then the person who are actually belonging to the first class has 63% survival rate and these are 24% survival rate. Then like when it comes to title and the social status, the person who are actually fair, so like whosoever is actually giving the high fare, which means that they must have get the first class compartment, right? So there's chances of survival is more higher compared to the other one, right? Then whosoever is actually having an age, right? So the children and the children and the older age people, right? So they have, or the women, right, they have actually given the higher priority, right? Then we will see like so, and we will see like what are the survival rate of cabin by cabin, right? What are the survival rate of upper deck and the like the lower deck and everything, right? We will see that what are the survival rate based on family size, okay? And if someone is actually traveling alone, so their survival rate, so the data says that their survival rate is very less, right? So I will show you. So let me first show you that how does data actually looks like, okay? Then I think then you will get to know a little glimpse about that whatever I am actually telling you will get to know, okay? So this is how bad my data looks like before cleaning, right? Before applying anything, this is how my bad data looks like. You can see that like first of all these two are actually irrelevant, right? And some column is basically like not filled, okay? And then you will see that some of them are actually not filled, okay? And there are many outliers also in this data, okay? So this is like, that is why I have chosen these data set, because this is a complete example of like producing the clean pipeline, the clean csv pipeline. So by like handling these kind of a data set, you will able to know that what are the all those details, keeping in mind what are the things that you need to apply, right, in the edr, in the feature engineering process, in the data cleaning process, in the imputation process, right? So I just wanted to like script this all this entire thing into your brain, so that the entire pipeline is basically you try to memorize inside yourself, okay? So that next time, suppose if I give you any model or any data, right, so any raw data, right, so you would know that what should be the pipeline that you should actually follow as a practitioner, right? So these, as you can see that this is very very dirty data, okay? So yeah, this contain a lot of outlier, this contain a lot of different name, this contain all lot of alphanumeric characters, okay? Then this contain so many things, right? And this contain like so many things, but the feature is basically limited, right? So from this I cannot able to derive everything, right? So that is why I needed the exploratory data analysis. So yeah, this is how my data looks like, right? Now let me just directly like go into the code, right? So first of all, what I have done is that I have just imported the model, okay? So this is like the pandas, numpy, and seaborn, and matplotlib, okay? So I am assuming that you know all these libraries. If you're not, then just let me know, okay, so that I will take a separate class of it. But I am assuming that because it is a foundational course, so you would know everything, right? So now this is actually I am importing this library, okay? So this is where like all this importing thing has actually happening, right? And why it is actually needed, because see, first of all, you cannot import everything in the very like in the at the middle of your process, okay? That is why you wanted to import every library at the very very top, right? Then the second thing is, yeah, so once you actually import all this library, okay, then the second thing is like you wanted to load the data set, okay? Once you actually load the data set, so your data set is actually looks like this, okay? So this is how your data set actually looks, right? So let me just let me just do all these things, right? So let me, if I just do this, right? So And if I just go and print out the, okay, so this is how my data actually looks like, right? So it contains a lot of things, right? This is my actual training data, right? And if you wanted to check the missing value, so from this, like, so if I just wanted to like check the missing value, so what can I do? I can just, you know, do this train, whatever the train df, right? And then let's say that I wanted to like perform that, if there is actually like, if there is actually contain, if this actually contain any null value or not, right? So from this I wanted to find out that how many is actually null value is actually there. So you would able to know that so like the passenger id does not contain any null value, right? So the age, right? So if you just wanted to find out this one, so you will able to understand that the age column, right? So whatever the age column, so there are actually 177 like null values basically present. Okay, so you wanted to like fill this null value, because you cannot able to, because this is just a data cleaning operation, right? So you don't want this, you don't want this null value to be present, right? So that is why it is actually needed. So let's go to the exploratory data analysis. Why it is needed, I already told you. Because you wanted to understand data more. Okay, you wanted to personalize yourself with your data set. Okay, so think data as if your friend. Okay, you wanted to teach something to them. Okay, but before teaching you, so you as your friend, you wanted some kind of like, you wanted to, you wanted your friend to remember some kind of a ethical value, right? In order to like sustain the good friendship, right? You wanted to tell what is the moral ethics value of the friendship, right? Before like moving it forward, right? The same thing, exploratory data analysis is just that you wanted to analyze the data, you wanted to get very in-depth intuition that how your data is actually looks like, so that you would know that what are the things and what are the like key points and what are the loopholes that you wanted to fill it, right? That is why. So this is like the overall survival rate, right? So this is basically the subplot, which means that like, so yeah. So as you can understood that I am actually using the matplotlib library, right? So here I'm doing is that I'm actually using like, so think this thing as an array. So this is first array and this is the second array, and inside this first one I wanted to like use the count plot. Okay, so count plot is basically sns. So sn is basically a seaborn library, right? So from the seaborn itself you wanted to like find out the count of the features, right? And which feature I wanted to count. So I wanted to count the number of survived people which is actually there, which is actually present, right? So you can actually see that these many people have not survived and these many people have actually survived, and this is very like, this is a very detail of my raw data set, right? And similarly, if I wanted to like find out the pie chart, so I can actually make the pie chart as well. Okay, you can see that x is 0. What is x is 0? This is my x is 0 and this is my x is 1. As I told you that I'm actually using this plotly library. Okay, so from the plotly, it is basically like returning two things. It is returning one figure object and one is axis. Okay, so if you just wanted to find out the type of this axis, so it is basically a array. Okay, and in the first array you are actually like plotting the count plot. In the second array you are actually plotting the pie chart. You will get every detail once you google it out, okay, about this library, because these things are very standard library in order to do AD operation. Okay, so in this case you will actually now get to know that there are actually only 30.38% of survival rate. Okay, then survival on the basis of gender. Okay, again the same thing, I am actually using the count plot here. Okay, and I am actually using the bar plot here. Before that I have actually like group by all those person, all those male. Okay, so I am actually grouping the number of male and the number of female. Okay, and then actually I am finding out the mean. Okay, so that I would able to get the percentage out of it, right? So this is my survival based on gender. Okay, so from this, what I have understood, that I have actually understood that there are female survival which are like 74% of the female has actually survived, and the count of female is 314. Okay, so there are 314 female which have actually survived, and there are 577 male which have actually survived, right? And these are basically the survival rate. Okay, these are actually survival rate, which means that let's say that I have the female count of 314. So out of 314, the 74% of the 314 female has actually survived. Similarly, let's say the male is like 577, so it means that only 18% of the male has actually survived, right? So around 1 to 3 like 123 or like 85 number of male has actually survived, right? Now similarly, if you wanted to find out the survival based on class, you can actually do that thing. Okay, so again the count plot I'm actually using, again I'm actually using the group by based on the class. So whosoever is actually belonging to some class category. Okay, So they have, so this data is basically show the passenger class and the survival rate. Okay, so I can actually understand that like these are the class and these are actually the survival rate. Similarly, survival rate based on embarkation port. So similarly you can actually find out, and then you will get the like all the details of the data, right? Similarly, when it comes to age distribution, again age distribution, I'm actually using the skeleton where I wanted to plot my graph is basically 2 2, which means that I have the matrices of 2 by 2 matrices, right? So I have like 0 0 0 1 1 0 1 1, right? So in the 0 0 I wanted to like do the histogram, okay, and like there I wanted to do the box plot. Why box plot is needed? Because I wanted to find out the outlier, okay, that whether like it contain any outlier or not, right? So these things I wanted to find out, okay. So these are basically the box plot, right? And then like the third is basically again the histogram, okay, which is going to tell you about this, and this, yeah, this is going to tell you about the number of survived and number of, so the frequency of number of survived and number of not survived, of all the things, right? So there are actually so this is basically the, I would say, the histogram of a combination of the two histogram of two classes, okay, the survived and not survived, okay. And this is basically the violent plot, okay. This is just give you the variance of it, like the more number of depth it is, which means that a more number of people like is basically, so it is like, if you would see, so it is like a Gaussian distribution around this one, okay, where the left side of Gaussian distribution, right side of Gaussian distribution, right? And this is like the zero means like whosoever not survived, and the one is like basically survived, right? So this is just a histogram of the age distribution, and from this, like what you can understood, we can actually understand about that the person who is actually belonging from the age of, let's say, 20 to 40, as actually like whosoever is belonging, so there are like around 70 people are actually belonging from age 20, right? So 20 to 25, right? And then like 40, like 30 38 to 40%, like 40 age group of people, so they have the count of around 45, right? And out of this, like how many people are actually survived and how many people are did not survive. So this is just a distribution based on the survival, right, of the same age group, right? So you can actually like understand from these two graph that the person who are actually belonging from age 20 to age 40, right? So out of this, like these many people are actually survived, okay, these many people are actually survived, and like these many people have not survived, okay. So yes, now the other thing is like the fair distribution. Fair means like whosoever is actually like taking the ticket, right? So they have the distribution, right? So this is basically the fair distribution. So now, yeah, okay, so now let's understand this. Okay, and again I am actually using the histogram, okay, in order to get the depth of the data, that how is actually data looks like, right? So this is like the fair distribution, okay, fair distribution, which means that so the amount of frequencies, you can see that a lot of VIP people, they have actually very less number, okay. It means that that the more number of people are actually belonging from 0 to 50 group, right? It means that these many people are like, maybe they have like they are actually traveling in an economy class to middle class and something like that, and these were people are like where like the are the very rare species where like they are actually paying a lot, okay, and their like their count is very low, okay. So maybe their chances of survival, I do not know, I will see it from the data, maybe that their chances of survival is far more prioritized, okay, because they have the very first class cabin, okay. So for them, the chances of survival or giving priority to them was actually the number one prior, right? So similarly, if you wanted to understand about the box plot of fair distribution, you could actually understand, right? So these are actually the like, so from the box plot you will understand that there is actually the 25, like 25, this is basically the quartile, okay. So this is like the middle quartile, this is like the 25th quartile, this is like the 95th quartile, and like based on 75 quartile, and based on that, let's say that this is my upper quartile, this is my lower quartile, okay. And then these are actually the outliers, okay. So I wanted to remove this outlier, so you can actually remove this, right? And then these are actually the box plots, right? So this you can actually try to like improve it and then remove it, right? And these are basically the statistics, right? So yeah, and then family size analysis again. So this you can actually see, like I have done it for my purpose, okay. So I'm not telling you that you should also follow the same strategy, I'm just telling you, I'm just giving you a glimpse that take this in mind, that you should, why you should do the EDA, okay, so that you could actually understand your data really well, right? So this is actually the family size, right? So family size, it means that this data is basically, so basically gives you a little more in depth of, let's say, the survival based on whosoever is actually having a sibling or whosoever is actually having a spouse, right? So their chances of survival, right? So like how many of them are actually survived, right? So yeah, these were the them, let's say that the whosoever is actually having a family of, let's say, 2 to 3, okay, 2 to 3, right? So they actually count, let's say that only five, only like out of 400, only 5 to 6 families were there, okay, who are actually a group of family where like they have a family sizes around 2, 3 and 4 and 5, okay, and these are basically the count of that family, okay. Then similarly based on parents and children, okay, so these are actually the sibling and spouse, and this is basically the parents and children, okay. And let's say the survival rate based on the family, okay. So these are basically the survival rate based on the family. We can actually see that the family who are actually like who has like around 4, okay, so whosoever is actually having a 4 family, okay, so they must have the women, they must have the children, they must have some elder people, okay. So they are actually very less in number, right, but their survival is around 72.4%, which means that the family who are actually having like the family who are actually having a size of around 2 to 3, okay, so they must have given the very high priority in the survival basis, okay. So similarly you can understand it from this data, and this is actually the correlation data, okay. So correlation is basically like before doing the feature engineering you need to do the correlation part, okay, so that which of those feature are basically correlated to the other feature, right? So these are basically the correlation matrices, okay. From this correlation matrices, what you can understood, just take a moment and just pause the video and just think, okay, that from this correlation what you have understood, right? So from this correlation you can actually see that these are my features, these are again my features, and I'm actually like making the matrices, okay. So you can actually see that from p class to fair, right? So these are actually having a very negative correlation. It means that if one is actually moving forward, the other is going down, okay. And if you could see that like the parch, right? So the parch and the siblings, okay, which means that there is a parent and children, okay. PAR means parents and CH means children. So the whosoever is actually having the parents and children and the siblings and spouse, so they are actually correlated with the 41% correlated to. It means that like if one is actually going in a upward direction, then there is like 41% correlation that they have actually like their sibling and spouse group is actually like also moving in that direction, okay. So they are kind of correlated, right? Similarly fair and survived rate, right? So like the fair and survived is also correlated, right? So there are actually 26% of like correlation rate, right? And again we have understood it from the data, right? So whosoever is actually paying a more amount, okay, so they must have given some huge facility, so their chances of survival is very more, like a very higher, right? So yeah, that is why there must be a correlation between this. So from this you can actually get a little insight about your confidence towards your data, okay. So whatever analogy that you make, okay, these things are actually like increasing the stacks of confidence inside you that might be true, okay, according to your use case and your view of data, right? Again this is actually the feature engineering. So in feature engineering what I have told you, I have actually showed you like the lot of data, and then I find out that the Mr., Mrs. and other things, okay, so these things are like I don't want the title, okay. So I don't want the title, so they basically like I have actually count out this title, and basically I try to like figure it out and try to do it in this kind of a distribution, okay. So in this way I would able to understand and I would able to know it, right? So again, so these are basically the create a family size, okay. So this is so what I have understood from the data is that from the feature, okay, whatever the feature I have the two feature of the family, okay. One feature is basically the spouse and the wife, right? So spouse and the sibling, right? And the other feature is like parents and children, okay. If I going to combine these two feature, then I will get a family, right? So why to increase the feature, right? So basically try to like concatenate this feature. So I am actually doing that here, okay. So what I have done is that I am basically like concatenating all this feature here so that I would able to know, okay. So that is why I can actually create one family size, okay, which means that I am actually combining, okay, combining the sibling and spouse feature as well as the parent and children feature into a one single family, so that I can get a family size out of it, right? So similarly there is a is alone feature, okay. So you can see I will share with the notebook with you, okay, so that you can understand that I have also written the why, okay, that why part of it, right? So like is creating a is alone feature because no one like so. And is alone feature means what? Like is alone feature means whosoever is actually traveling alone, okay. So we have like shown it statistically that they have the chances of survival rate is very low, which means that like they kind of lost their life, right? So yeah, so being alone may affect the survival like differently than being a family, of course, because those who have a family has given that very top priority, okay. So these things these I wanted to find out, okay. The survival rate of let's say alone passenger is 30.35%, and the family passenger is 50.56%, okay. So from this you would get a little intuition, right? That suppose if I give you a data, Just forget about the machine learning part. Just understood it. Suppose if I give you a data, right, and if the data contain the family size, let's say 2 to 3 or more, then intuitively or statistically what you have get. So suppose if I tell you that whether this data, based on your intuition, that whether this person, like whether this entire data is coming into a survival category or not survival category. So till now you have around 50% chances that by seeing the data you could understand that, okay, because these like the data contain a lot of family group, okay, so I would definitely go and put this data into the survival category, right? Because till now whatever you understood it from the ED feature engineering, just this part only, right? Again, you wanted to create a fair bins, okay, because if you see, the fair is basically a numerical data. You don't want a numerical data, you wanted to create it into the different bins, okay. So these are basically the bins I have. So I have categorized it into the low bins, medium bins, high, and let's say very high, okay. So let's say the whosoever is actually having a fare of, let's say lying between lying between 20 to 100, okay, 20 to $100, okay. So if I just like divide it at a 20 to $100, so in between 20 to $100, let's say I have a lot of distribution, right? So I can actually equally divide it into 5 phases. So let's say whosoever is actually paying around 20 to 30 should come under the category of low fare, okay. Then from 30 to 40, medium fare. Then from 40 to, let's say 50, like 40 to 70, let's say it's come into the high fare, okay. And then like from 70 to 100, that is actually come under the category of very high fare. So in this way I actually distributed into the fare bins, okay. So these are actually so binning is very important in feature engineering. Wherever you see that you have a some kind of, wherever you see that if your data is basically kind of a classification supervised data, okay, then it's always better that you wanted to like decrease the like the feature who are actually having, or convert the feature who are actually continuous into the bins category or in a categorical category, and that way you could able to divide the data really well and very clean manner. That's why, right? So you can actually see that. So I have actually divided it into these category, okay. So the amount of people is actually like there are 220 there are like around 223 people who actually come in the category of low. There are 224 people actually come in the category of medians, and then so yeah, 225 like 215 around is come in the category of very high, okay. And these are actually the percentage. Similarly, I have an age group also, okay, age group also. So I have also divided the age group into these categories. So whosoever is actually belonging from like age group of 0 to 12 are basically a child, then 12 to 17 a teenage, then 17 to 25 a young and adult, 25 to 60 are basically adult, and then 60 to 100 is basically senior. And I have divided into these categories, and actually find out that the children are basically 57%, right? The teen are some 45%, and these things you can actually find it out, right? Then similarly hash cabin, which means that you can actually like find it out. The survival rate of a person like who has the cabin is 66.667. That's really huge, right? Which means that those who can, very least people from the data we can understood that very least people have actually like try to afford these cabin classes, okay, and their survival rate is like around 66, like around 67%. So you can probably guess it like how the survival rate possibly could be, right? Similarly, again the deck wise, again this is actually data cleaning part. So data cleaning part, what happens is, as I already shown you the data is actually containing a lot of like missing value, right? Or so either you can just do the imputation or do the NaN or creators like, or put the zero out of it, or like put the median like in the empty part, right? So you can actually do that thing, okay. So this is basically like imputing the age with the median and title, okay. So age varies from like master to child, so like impute it. So you wanted to impute and you wanted to do the imputation part. Similarly, you will do the other part, okay. You wanted to drop the unnecessary column, okay. From the correlation we have actually find it out that these are actually the unrelated column, or these are actually correlated column. I don't want that, right? So what are the column that you wanted to drop? So I wanted to drop, again it's completely personalized. You can do and prepare a data set by your own. This is my practice, this is what I follow, okay. So like the passenger ID, the name, because I find out that passenger ID has no significance to predicting the survival and not survival. So that is why I deleted this. Then again, name has so name is actually irrelevant, right? So that is why I deleted this. Then ticket, then cabin is actually like not related to the survival. Similarly, you can also drop the family size and then fare log, because I have already concatenated and combined the family size, right? So I don't want this family size, so I'm actually deleting this part. Encoding part is very important, right? So encoding part is important. Why? Because let's say as you can already see from the data itself, that these are actually the categorical column. Okay, so in order to like convert this categorical column into a very, let's say, into a very scalable way, so that you so from the human point of view, you would see that your data becomes lengthy, but from machine point of view, it becomes very very easy, because the data is like containing into a, so the categorical data, so the feature which is actually having a categorical data like 010101, now it has basically, we have actually done the one hot encoding. Okay, so rather than just like extending the data into 0101, I am just like expanding the data horizontally. Okay, in this way it could be better for a machine to understand, especially when it comes to decision tree. That's why, because decision becomes very very fast in that way. That's why. Then okay, so this was nothing, so let me just put it, because these things are optional, right? And then again, finally, once you have like done all this data and once you have cleaned this data, so this is your data looks like. Okay, so what is your final set of data? So this is actually your final set of data. Okay, and these are actually the final column. Okay, and these are the test column, these are training column. Let me show you that how does data looks like. Okay, so yeah, this is where I am actually saving my data. Okay, and this is like the summary. Okay, that what I have done till part, right, till now, right? So I have just imported the model. Okay, I have done the EDA, I have done the feature engineering, I have done the data cleaning part, I have done the encoding part, I have done the final check. I am just like save the cleaning model. Okay, let me show you that how does data look like. See, as you can see that now this is very clean data. Okay, anybody could see that this see the data, they see this data, they can actually tell that okay, this is very clean data. Why? Because this data does not contain any kind of noise, number one. Number two is this data is not correlated, so all the necessary correlated feature has been removed. Then this data is also containing a very clean and structured way of like representing the one hot encoding. Okay, so as you can see that in the gender column, right, so I have zero, I have male and female, right? So I'm just like increasing it horizontally. Okay, so that when it go to the decision tree, so the decision becomes very very faster. That's why, right? So in this way, like, yeah, so see how good the data is actually looking, right? Isn't it? See, it does not contain any, like, it does not contain any more any such row which is like containing any NaN value, right? Any null value. So it is like completely imputed by completely imputed by either the median value or via zero. Okay, so I basically like, and as you can see that this is basically which column is that. So it is basically fair column. So you could see that some of those fair column earlier it was like containing a lot of outlier, right? But after removing the outlier and then like after imputing the empty value with the mean of the entire column, right? So how it looks like. Okay, so this is how my clean data looks like. Okay, now let's completely go to the training part of it. Okay, so yeah, so this is my training part. Okay, let me reconnect, or basically I have already trained the model, right? So yeah, I hope you can see this, right? Yeah, so now this again, so I'm just actually loading my model. Okay, so let me go up. Yeah, okay, so this cell is basically just loading my clean data set. Okay, I am just loading my clean data set, and then what I'm actually doing it in the second phase is now. So before first of all, just understand that I have the data, right? I want, and this is basically a classification data, right? So I need to like apply a lot of classification algorithm from the ML supervised learning algorithm, whatever algorithm I have the classification. So I have like the XZ boosting, I have the logistic regression, I have a decision tree classification, I have a cat boosting, I have a gradient boosting, I have adaptive gradient boosting. Okay, so these things I wanted to like apply it, right? But before, because it is a binary classification, so my first motto is to check that whether it is actually a linearly separable or not, right? Because if it is a linearly separable, I would love to go with the logic, like the linear regression, or let's say the logistic regression. Okay, because I can just create one line and I can just have the better suitability of the classification. I can just do the classification in that way, it would be very easy. So I just wanted to see that thing. That is why I have just applied the PCA operation. So PCA is basically, I told you in the previous lecture, PCA is basically the principal component analysis. Now what does it do is that it try to, suppose your data set is actually like before, like your raw data set, if you wanted to represent it into the graph, right? And if it is actually needing, let's say, more than 64 feature. Okay, so if you wanted to represent data into the 64 feature, it would not be a very possible way, because a single line cannot be able to easily separate each and every part of the data. Okay, Now PCA is basically a technique which is try to reduce the dimension, so it will actually basically reduce the number of feature. Okay, so that why, so let's say that if I have 100 feature, okay, and if I reduce that 100 feature, let's say into 3 or 4 feature, okay, now does that mean that there will be a data loss? Okay, there might be a data loss. Why? Because I am actually reduced from 100 feature, I am actually reducing it to the 3 feature. Okay, now how many data loss is there, or whether this 3 feature, out of this 3 feature, how many percentage of data is actually showing? Okay, so these things PCA handles it. Okay, so PCA is basically a dimensionality reduction technique or a feature decomposition technique, or not a decomposition, feature reduction technique. Okay, so that your feature is basically reduced, so that you can actually represent it into the 2D graph, right? That is why actually PCA is needed, right? So that is why if you see that thing, I have actually the number of component is 2, which means that, so basically let me tell you that what are the things I have already imported, right? So these things are actually I wanted to import. So matplotlib again, and scikit-learn is basically a library. Scikit-learn is basically a very standard library where you contain a lot of machine learning, let's say algorithms. Okay, if I just go to the scikit-learn, just in free time you can just see that you see this thing, right? So if I just go to scikit-learn, right, see this part, just see the documentation, because I also learned from that this way, right? So scikit-learn is like it has some kind of a classification, it has a lot of classification algorithm, and like month by month they are actually updating it. Okay, they come up with a lot of different algorithm which might be good compared to the traditional machine learning algorithm. Okay, they have the algorithm regression, these many regression algorithms, some part of, like some of it we are not actually using it, right? So you can do it by yourself. I think that is your very good task to implement and do the hands-on machine learning in that way. This is actually the clustering. Okay, I already showed you, right? So it has actually db scan, k-means and other things, so you can actually do the hands-on practice on scikit-learn. Again, coming to the lecture, as you can see that this is like the explained variance. Now what does this, so yeah, again, what does this PCA will do? So again, first of all, this is my all the libraries which I have already imported. Okay, and like this I have already like applied and show you this thing, right? Again, this is basically the PCA part is what? PCA part is like dimensionated reduction. And what is explained variance? What is this explained variance ratio? Okay, explained variance ratio is basically tell you that if you reduce the dimension, right? So let's say from 100 to 100 feature to 3 feature, if I reduce it, definitely there will be a data loss, right? Then from this 3 feature, how many percentage of the data which was earlier, let's say 100 feature, it is actually showing 100% of the data right now, but I have actually reduced it to 3 feature. Okay, so via 3 feature, how many percentage of the data which I am probably like understand, right? So this is like 28.3% of data, which is not really good. Okay, because though it is actually converted into the 2D dimension, but I am not very confident that I can basically try to like segregate this data via single line. Okay, even if I do that thing, that would be a very bad machine learning algorithm, because if I pass it to my model, like if I pass those testing data to my model, I would not get a very good accuracy, right? That's why, again, with the 3 dimension, if you see, so if you just let me show you, so yeah, this is like the 3 dimension data set, right? As you can see that I cannot like easily segregate, because this data is entirely mixed up, right? Even if I clean the data, this data is entirely mixed up, which means that even if I just create a one single line out of it, right, so I could not be able to like do it, because this data is actually mixed up, right? And this is supervised, right? So it has all this supervisor. I cannot like do any kind of a, I would say, manipulation with the clean data, because data is data, right? I can only like do the cleaning part, but I cannot change the value, right? Because value is very, very important. That is why as you can see that thing, that these are actually the real value of the data, right? And even if I just create a one single light, though it is a linearly separable, but it is not very good. Okay, so that is why this is actually the 3D way of doing the PCA representation. Okay, and then this is like if I actually increase and do some other thing, you will get something like this. And so this is basically TNSE visualization, right? So now what to do next? So just call, so my agenda of doing this thing is that I will implement each and every machine learning classification model which actually exists in the domain. Okay, which means that I have a logistic regression, you know about random classifier, you know about the gradient boosting, you know about the voting classifier. I don't need to tell you again, because I told you in all the previous lecture as well, right? This is like the support vector classification, this is the k nearest neighbor, this is like the light boot gradient boosting, this is the classifier, this is the cat gradient boosting, right? Now what I'm supposed to do is that this is my data, this is my very clean data. I have actually divided the data into the X and Y category, which means that X is basically going to contain the non-target value, and then Y is basically the target value, right? Which I wanted to predict, okay? Because it is supervised. So I am actually doing that thing. Now let me tell you one more example of why I am doing this thing, okay? So this I am actually doing the 5-fold cross validation. I have already given you a lot of example in the cross validation before, right? That what is basically cross validation. So let me tell you one more time. Here I'm actually using the, so you can ask me that why are you not splitting the data into direct train and test? You could just split the data into 80% of the data you could have just given it to the train data, and the 20% you could have just given it to the test data. Like why are you doing this, right? Because by doing the cross validation, right, you may able to minimize the overfitting, okay? My main purpose of using the cross validation is to minimize the overfitting. My main purpose of using the cross validation is to find out, let's say, doing the hyperparameter tuning, okay? That is why cross validation is very, very important. Here my main purpose of doing the cross validation is to just find out the accuracy, which means that whatever training data set I have, right, I am actually dividing it into the 5 subset, and each subset, right, each subset I am actually training the entire, like, one model one by one. So I am training, let's say, logistic regression. I am actually finding out, let's say, the cross validation accuracy, okay? Like if I just, so if I just divide the data into the subset of, let's say, 5, okay, 5 equal part, right? So the first 4 I am actually training my, let's say, logistic regression model, correct? And the last one I am actually testing it, and I will get some accuracy. Then what will I do? The second part I am actually keeping it as a testing, and then the first and third and fourth and fifth I am actually using it as a training data set, okay? And then again I am testing it with the second subset, okay? And then again finding out the accuracy. Similarly, I'll just repeat this process till up to n-1 step, okay? And just finding out the cross validation accuracy, and like taking the median out of it, okay? So that is why if you see, I am just applying the cross validation for like training the model each one by one, okay? So first I am actually training the model with cross validation. First I am training the logistic regression, then random forest, and then other thing as well, okay? And inside this I am actually giving the hyperparameter as well, okay? These are my basically the hyperparameter, okay? And this I am actually splitting it into the cross validation error, right? So via cross validation technique I have done the training part, okay? So I have not done the training part, I'll do the training part after that, right? So let's say that, yeah, so this is just some cleaning which has already been left in the previous step, so I am just doing this. You can just ignore it for this one now. Yeah, let's do the training first, okay? So what I'm going to do is that whatever model I have, let's say that these many model I have, right, I wanted to train the model sequentially, like one after one, right? So what I can do is that I can just create a, like, I'm just iterating the model one by one, okay? In order to understand about that how much time it is taking, I'm just using the time, the import time, right? And again, I'm just finding out the cross validation error. I'm just finding out the mean. Why mean is necessary? Because for, let's say, for one algorithm via cross validation, because it is actually like I'm dividing it into a subset of 5, so that is why I need the average of 5, average of the accuracy, okay? Average of the accuracy of all the 5 subsets, right, of a single algorithm, okay? So that is why I'm doing. And finally, once you're able to train it, right, you will get something like this. Now this is very, very important. Why? Because I am not biased towards, as a practitioner, I am not biased towards a one machine learning model, okay? As a practitioner, I should actually like try and test it to every classification problem, or every classification algorithm which actually exists, right, in the domain, right? So yeah, this is why I've just using these many algorithm, and you can actually find it out that I will, like, I have get a pretty good result, right? I have get, like, again, why boosting, that is why I'm telling you that why boosting is very, very important, right? That is why I'm telling you that why XGBoost and all the variety of boosting and all the terms I have given you in the previous lecture, right? In that, why boosting is very, very important, right? You can see that, like, the cat boosting is actually giving 84% accuracy, and this is not even like overfitted data, right? Because of like using the cross validation policy, okay? That is why it is very, very important to do this practice, right? Again, if you wanted to like show it into the good table, you wanted to show it like, you can actually show it like this, right? So XGBoost and like this is the other boosting variety, right? So these two have like neck to neck competition. Like one is actually showing the 83% accuracy and one is actually showing the 84% accuracy, right? Because our data set is very low, so that is why it is just taken 4 seconds. Like it is just taken to 4 seconds. And you would sell that, you would tell that, like if my data set, it looks like in millions and billions of data set, right? So it will take, like you can actually like try it by yourself, that how many time it takes, right? If you have a good compute, it will able to train it very very faster, right? So training also, so it has also effect on the training time, right? So training time is also like very very important when it comes to like practicing machine learning, like training, right? So this part is very very important. That is why data cleaning and things is important. That is why cross validation is very important, right? And again, you wanted to pick the best model. Okay, you wanted to try out, let's say, the testing data. Okay, so these are my, let's say, that test clean data I wanted to try out. I wanted to try this out, so I have actually tried it out. And basically these are the matrices which I have already showed you before, that I have confusion matrices, I have a precision, I have a recall, I have F1 specificity matrix, all these things, right? So you can actually say that, like on the testing data, it is kind of giving me the 91% accuracy. Okay, which is like pretty good, right? For the data that we have taken. Okay, so for the data, for the dirtiest data that we have taken, like which has nothing, right? We have done all this feature engineering part, all this AD operation, till up to cleaning part, till up to correlation part, all these statistical like understanding and other view of the other view analysis, and then like completely like choosing the best algorithm, choosing all the algorithm, like choosing the best cross validation, like choosing the best algorithm using a cross validation technique, and doing the doing the training really well, and in a very small optimal time. You would get a little glimpse about like how the production machine learning pipeline works, right? What is the best practices of doing this machine learning way? Okay, so you can see that I'm actually getting the testing accuracy, which is really good. Okay, now whether it can be improved, of course it can be improved, right? So that is like, that is your task. You can actually like take this data set from Kaggle, and then you can actually try to improve it by yourself, and just let me know that how many accuracy you got, right? So, and then again, you wanted to like save this machine learning, export this machine learning model, so you can basically try to export it into .pickle format or AD format, so that this is the pickle file, right? This is the pickle file. Let me show you. So this is basically the pickle file that you would actually forward it to your teammates, right? So that your testing team, right? So that basically whosoever is actually making the UI, they can actually like try to import your model and try to test it into a real life data set, right? So that is very very important. So till now, yeah, whatever things that we have done is that we have actually trained the model, we try to export it into a .pickle format, and these were actually our testing accuracy. Okay, so let's revisit the entire pipeline that we have done in today's implementation. The first thing is that we have actually defined the problem statement. So the very first cycle of machine learning process is that you define the very problem statement. You get the raw data. Okay, you get the data in columns and row. Okay, then you basically try to understand that whether I can solve this problem using a supervised or unsupervised learning. Then the second thing is that you load your data set. Okay, then your data set is completely unstructured, right? So you wanted to understand, so you basically apply, like you wanted to understand the feature of it. Okay, that how each and every column is basically what it is telling you, right? Given the data which has been provided to you, either if you're working in a, let's say, in a very industry use case specific data, right? So you should ask the problem statement, that what should be the problem statement, what does this data contain. As a practitioner, never like be in doubt that asking question about your data set, because in machine learning, when training a model is later part. First of all, understanding your data is very very important, right? So that is why understanding and taking the very crisp inside of the data, and then later doing the feature engineering, later doing the exploratory data analysis, then data cleaning part, then encoding the feature, whichever feature is actually having a categorical value, then you wanted to import it, then you do the splitting. So I basically prefer the cross validation splitting instead of training and test split, to avoid the overfitting issue. Then you basically go and train your model, then you select, then you train, let's say, on multiple model, you select your best model. After selecting the best model, you try to like provide your testing set, right? So whatever testing clean data set, right, you wanted to test it on your trained model, right? And then you wanted to take out some assumption, and then you try to like pass it over to other team, right? You wanted to export the model in whichever category you want, right? And then you pass it, and then final phase is basically a deployment part, right? So this is, guys, complete machine learning cycle. If you understand majorly all those 85 to 90% problem, you will try to understand that you will follow these kind of a pattern, because this is very very generic to any machine learning practitioners whosoever, whether you are in like working in a beginner domain or a let's say or in a, or you have gained some experience, right? So you will definitely follow one pattern, which is like by following these kind of a predictive cycles. Okay, so these things are really really important and helps you to understand the all these, all this understanding and in-depth analysis of the data. Okay, because in ML, data is everything. Okay, so if you have a question, so you can just drop it below. Okay, I will get to know about you, like whether you have understood in which like point you wanted to get more insights. I will just follow it through you. And this entire machine learning foundation, again I'm telling you, so this I have already like conceived in a way so that you already know it, right? I am just refreshing the concept again. If you want a very in-depth analysis and in-depth lecture of machine learning, where you wanted a in-depth statistical like method and your all those mathematical details, right, and how those each algorithm work and everything, so I will come up with all these things. But for now, we will, in the next video, we will be moving forward to our neural net computer vision section, because that we are actually entirely concerned, very very concentrated on, right? So yeah, that thing I just wanted to show you as my feedback to recording all set of lectures, and then try to understand the your way of that how do you actually like implement all these things in a very easiest possible manner, right? And yes, so if you really wanted to understand like how I have learned all these things, so basically like I have used this book. So this is not any promotion, so this I have just used it by my own learning, which is like O'Reilly. So O'Reilly is like hands-on machine learning way. So this you can just take it and just read it in one go. So I think you will get a lot of intuition from this, right? So it contains all those image processing thing, all those machine learning full stack. If you really wanted to understand the data science, then you will really like try to do and learn from this book, because I generally refer this book also, right, to understand the everything about whenever I feel any issue, or any like whenever I feel underconfident, I will definitely go and refer this book. So this books and documentation part, again, go to the scikit-learn documentation, always go to the official documentation and try to understand it, rather than just doing the chat GPT thing. Okay, always follow the documentation, always follow the official documentation of the model, wherever whosoever is delivering the model, just follow their GitHub repo. You will get a lot of insights from this. Okay, so yeah, this is just last node, and I hope you understand all these lectures, and let's meet to the another lecture. Thank you all.